This already we have discussed, that is velocity relation in orthogonal cutting. So just I will brief this, that we have seen that there are the three velocities which are involved there, and as far as the mechanics of metal cutting is concerned. So what are those velocities? That is first one is nothing but we can say it is the cutting velocity v. Then we can say, what is v? Basically velocity of the tool with respect to workpiece. So that is nothing but called as the cutting velocity. Then second velocity, that we know, that is nothing but the Vs. So this one is the Vs there. So what is Vs? That is the velocity of the chip with respect to work, and it is nothing but called as a shear velocity. Then there is a chip which is flowing there, and as the chip is flowing, so again that chip is having a certain velocity. So that is nothing but called as Vc. So what is Vc? Velocity of the chip with respect to tool face. So that is nothing but called as a chip velocity. And here, so these velocities are there. So whatever these velocities are there, so these velocities can be plotted there in a triangle. So that already we have seen. So these are the velocity which we have plotted there in the triangle. So here we can say this one is the cutting velocity. So that is nothing but the v. Then we can say this one is nothing but the shear velocity. So in the same way, and whatever the velocities we can find there in the mechanics of metal cutting, so same velocity we have plotted. So in this direction, so this one is nothing but the v, cutting velocity. In this direction, so it is acting here you can find in this direction it is acting, so same we have plotted over here. Then we can say Vc is acting in this direction. So here we can say here this one is the Vc from the mechanics of metal cutting. So here we can say Vc can be plotted like this. So if you plot a vertical line like this, and here also if you plot a vertical line like this, then whatever that angle is nothing but, so that angle is nothing but called as a rake angle. So here also you can observe, so whatever this angle is there, so this angle is nothing but we can say it is the rake angle, and it is nothing but the rake angle. So basically this total angle from this dotted line to this v, so it is 90. So if you subtract this alpha, that is rake angle, so this angle will be nothing but equals to 90 minus alpha. So very simple. So again next thing, this one is the cutting velocity and this one is the shear velocity. So here we can say this one is the cutting velocity and this one is the shear velocity which is acting along a shear plane. So what is this angle here? So we know that shear plane is making certain angle with a horizontal, and that angle is nothing but called as a shear, angle. So here also same thing we can write. So this is the v, this is shear that is the shear velocity. So whatever this included angle is there, so that included angle is nothing but we can say it is the shear angle phi. Then we have to calculate that what is the angle at C. So this one is the point C. So what is the included angle at this point C? So that we have to calculate. So as usual, very simple. What we can do, that already we have discussed. That is the total addition of this angle is nothing but equals to 180. So 180 minus this angle, 90 minus alpha, plus phi. So if you subtract the angle, that is angle at A and angle at B, so we are going to get the angle at C, that is 180 minus angle at A plus angle at B. So we can get the angle, whatever the angle which is there at C. So accordingly we can get that angle, that is 90 plus alpha minus phi. So that already we have discussed. Then after that what we are going to do? We are going to apply the Lami's theorem, or we can say we can apply the sine rule. So using sine rule, so what we can write? Whatever this side is there divided by sine of this angle, and whatever if you consider that is Vc, and if you consider Vc, so here we can say Vc, we can consider here Vc. So this side divided by sine of this angle, and same thing we have written over here. So here you can observe that is Vc divided by sine of. So here this one is the VC. So divided by this angle, sine of this angle. So here same thing, VC divided by sine of phi. Then we can say Vs. So this side divided by sine of this angle and a sine of this angle. So we can say Vs divided by the sine of 90 minus alpha. 90 minus alpha. So this you can get there. So again you can find same thing, that is VC. Same thing we can write. So VC, Vs we have write in the same way we can write V. So V divided by sine of this angle, that is angle at C. Angle at C. So accordingly we can write, that is V divided by sine of, what is this angle at C? 90 plus alpha minus phi. So accordingly same thing we can simplify, and we can get the value. We can get the value that is we are going to get the relation there, that how to calculate VC in terms of this V and sine of phi and alpha, and in terms of this V sine of phi and alpha. So this is what is we have got the relation. So from this one we can write VC is nothing but equals to, so here we can consider this 2, that is VC and this V. So we can write VC is nothing but equals to, we can multiply this, we can cross multiply V sine of phi divided by the sine of 90 plus alpha minus phi. So 90 plus alpha minus phi. So sine of 90. So what we can write this one we can write, we can take minus common, so we can write phi minus alpha. So this we can write, that is nothing but phi minus alpha. So if you take the 90 common, so we can say here we can write that is 90 minus phi minus alpha. 90 minus phi minus alpha. So sine of 90 minus alpha, so it is nothing but equals to cos of alpha. So same way cos of phi minus alpha. So here we can write, that is V sine of phi divided by cos of phi minus alpha. So if you know the cutting velocity V, if you know the shear angle phi, so from that we can calculate the value of VC, that is what is the chip velocity, and what is the chip velocity. So in the same way we can calculate, what we can calculate, we can calculate Vs also, and we can calculate Vs also. So here again we can write Vs. So we can consider these two terms, Vs and this one. So in terms of this V, we can calculate Vs. So what is Vs? Vs is nothing but, again we have to cross multiply. So V cos of alpha divided by that is V sine of 90 minus alpha divided by sine of 90 plus alpha minus phi. So V sine of 90 minus alpha is nothing but equals to V cos of alpha divided by sine of 90 minus alpha is nothing but cos of phi minus alpha. So here I have written same thing. So here we can say that is cos of phi minus alpha. So if you know the cutting velocity in the same way, and alpha if it is known, then we can say shear angle if it is known, so we can calculate the value of shear velocity, and we can calculate the value of shear velocity. So basically in the numerical, cutting velocity may be given, phi may be given, alpha may be given, and we have to calculate the chip velocity, or you have to calculate the shear velocity. So for that purpose whatever the known terms are there, so in terms of this known terms, so we know the relation, so accordingly we can calculate this VC and shear velocity, and VC and shear velocity. So next thing, we know that how basically the material is going to be cut there from the mechanics of metal cutting, how the material is going to be cut there from the mechanics of metal cutting, so that we know. So from the mechanics of metal cutting, so we know cutting tool is exerting the pressure, and because of that pressure, material is going to be sheared there, material is going to be cut there along a plane, and that plane is nothing but called as a shear plane. So when the material is cut, so it will be cut there in the form of the chip. And so here in this sketch you can observe that is in this way basically whatever the material which is cut there, so that will cut there just like this saw tooth structure and a saw tooth structure. So in this way you can find the material can be cut there. So how the material is cut? So basically you can say the shearing process is analogous to the displacement of a stack of a card. And whatever the shearing process which is taking place is just like we can say stack of a card, with each card sliding slightly over the adjacent card. And each card is sliding slightly over the adjacent card. So in that way basically you can find material is going to be cut there. And who is unmuted? Unmute yourself please. And yes, anybody is not muted, and I request all of you to unmute yourself. Yes, unmute yourself, all of you. Okay. And so from this model basically we can calculate that the shear strain that the material is undergoing, so that can be determined there, and that can be determined there from this particular model. So one thing is again clear, that we know material is cut there in the form of the chip. And what are the different types of chips? So that already we have discussed. There can be a continuous chip, discontinuous chip, then continuous chip with the built up edges are there, and the next one is nothing but we can say the segmented chip is there. And so whatever the maximum engineering materials we machine, so in the machining of this maximum engineering material, so this is what is the chips which is going to be cut there. So these are the different types of chips. These are the chips which are going to be formed there. So that is nothing but we can say it is the segmented type of chips, and a segmented type of chips which are going to be formed there, So from this we can calculate the shear strain. So for that purpose what we are going to do, that we are going to draw a horizontal line, and a horizontal dotted line we can draw. So here you can observe that is from point C to A, and I have drawn the horizontal line. So that is nothing but the AC. Then from this point A to the point where this cutting tool is touching there, so that is nothing but the cutting tool which is touching there at the point or at the workpiece. So that is the point B. And so here you can observe that is the point B. So this triangle I can consider, that is ACB, and this is what is the triangle I can consider there. So if I consider the triangle ACB, then we know here that this one is nothing but the horizontal line, and this one is nothing but the shear plane, and along which basically material is going to be sheared. So this is the shear plane there. So whatever the angle which is made by the shear plane with the horizontal, so that as usual that angle is nothing but we can say it is the shear angle. And so here you can observe this one is nothing but the shear angle there, So same triangle we can draw over here. So here you can observe that this one is nothing but the AC, this one is nothing but the AC, this one is nothing but the AB, and this one is nothing but the BC, and this one is nothing but the BC. So whatever this angle, so if this angle is alpha, so here you can observe this angle, and so here you can see if this angle is alpha, so we can measure this angle, and we can calculate this angle. So what will be this angle? So opposite angle. So here this one is the opposite angle, so we can say this angle is also alpha, and this angle is also alpha. Then what we can do that whatever this point C is there, so basically at point C if you draw the vertical line like this, and and the same line if it is extended like this, and so this one is the straight line, just consider. So whatever this angle is there, so what will be this angle? So here we can say when the vertical line is drawn like this, so this angle is alpha, and so here you can observe this angle is alpha. So when this angle is alpha, so what will be this angle? It will be alpha, So here also what we can do, we can draw a vertical line like this, and accordingly if you consider there this total angle, and if you consider there this total angle, so this total angle, what will be this total angle? So this total angle will be nothing but equals to phi, and this total angle will be nothing but equals to phi. And what will be this angle? What will be this angle? This angle is nothing but we can say it is alpha, and this angle is nothing but we can say it is alpha. So are you getting me this? And so very simple that we know how the material is going to be cut there in the actual practice. So this case we have drawn. So we know that is in the way that is teeth of this saw, and in this way the material is cut there into the discontinuous pieces. So into the discontinuous pieces like this material is going to be cut there. So what we have drawn, we have taken there the triangle like this, and A, B and C. This is what is the triangle we have taken, and same triangle I have drawn over here, and same triangle I have drawn over here. So if this is alpha, this angle will be alpha. So here accordingly we can say this angle is also not alpha, this is angle phi. So accordingly this angle is also phi, that is shear angle. So accordingly here we can say this angle is also shear angle, that is phi. Then if you draw a vertical line like this, and if you draw a vertical line like this, then this angle is alpha, this angle is alpha. So accordingly we can say this angle is also alpha. So here also you can observe, if you draw a vertical line same from this point C, so this angle is alpha, and this total angle will be nothing but equals to this phi, and this total angle will be nothing but equals to this phi. So that total angle, if it is phi, then we can calculate this total angle. And so before to that, what we have done, that is from this point C, we have plotted the dotted line, that is we have drawn the perpendicular on the line AB. And so what we have done before to that, from the point C, here you can observe, from the point C we have drawn the perpendicular line, normal line on this point, on the line AB, that is on the shear plane AB. So accordingly this angle is nothing but we can say it is 90 degree, and this angle is nothing but we can say it is 90 degree. So here also in the mechanics of metal cutting, here also you can observe that from this point C, if you draw a perpendicular on this A, and if you draw a perpendicular line on this AB, that is on the shear plane, so same thing here I have drawn there, so accordingly whatever the angle which is made by this perpendicular line and the straight line, so that angle here I can say this total angle is the phi, this angle is alpha, and this angle, and here I can say this angle, so this angle is nothing but we can say this total angle is phi, so phi minus alpha, so that will be that angle, and that will be nothing but we can say this is the total angle, that is phi minus alpha, and that is nothing but phi minus alpha. So how we can calculate the shear strain, and how we can calculate the shear strain. So what is meant by shear strain? So that is nothing but we know the shear strain, change in length divided by delta L by L. So from the mechanics of metal cutting we know the shear strain. So here what we can say shear strain. So shear strain is nothing but we can say, we can denote it by S, and we can say shear strain is nothing but equals to distance shear. Shear strain is nothing but we can say it is nothing but equals to distance shear divided by thickness of shear zone. And so what is nothing but the shear strain? We can say it is nothing but equals to the distance sheared divided by the thickness of shear zone, distance shear divided by the thickness of shear zone. So that is nothing but we can say it is the shear strain. It is nothing but the shear strain, and we can denote this shear strain by S, and we can denote this shear strain by S. So what is distance sheared? And distance sheared, so where the distance is going to be sheared, or where the shearing is going to take place there, and shearing is going to take place there on the shear plane. So along this plane, that is here in the mechanics, so we can say along this plane the material is going to be sheared. So what is the distance sheared? Distance sheared is nothing but we can say it is AB, and distance sheared is nothing but we can say it is AB. So AB is nothing but we can say it is the distance sheared. distance shear. So what is the thickness of shear zone? So thickness of shear zone. So what will be the thickness at which the material is going to be sheared, or what will be the thickness there? So this one is nothing but the thickness. So here you can observe this OC is nothing but the thickness. This OC is nothing but we can say here thickness. So distance shear, that is AB divided by OC. Divided by OC. So that is nothing but we can say the shear strain. Shear strain. So very simple. Again I can repeat. What is shear strain? That is the distance sheared divided by thickness of shear zone, or thickness of zone, or we can say thickness of shear zone. So what is the distance sheared? So definitely distance sheared material is going to be sheared there along a shear plane, whatever the length of the shear plane is there. So that is nothing but the distance sheared. So here I can say distance sheared is nothing but AB. Here you can observe AB, that is nothing but the distance sheared. What is the thickness of shear zone? So this one will be nothing but the thickness there. This one will be nothing but the thickness, that is nothing but equals to OC. So what is AB basically? So we can say AB is nothing but we can say it is AO plus OB. AB is nothing but we can say it is AO plus OB divided by, as usual, that is OC. Divided by this OC. So how we can write? It is nothing but equals to AO divided by OC plus OB divided by OC. OB divided by OC. So what is AO? So consider this triangle. So for calculating AO, so what you have to do? You have to consider the triangle as usual again. Consider this triangle. So what is AO? So this is the distance AO. Here you can observe that this one is the distance AO divided by this is nothing but OC. So here you can observe this angle is nothing but equals to 90. This angle is nothing but equals to 90. So if you consider AO divided by OC, so basically what is this? This is nothing but the adjacent side divided by OC. So this one is nothing but we can say it is the opposite side. So what is that relation? So it is nothing but the cot of phi. So if you consider the angle cot phi, then cot of phi is nothing but equals to this is the adjacent side divided by opposite side. Adjacent side divided by opposite side. So accordingly we can write there that is AO divided by OC. So what is AO divided by OC? So AO divided by OC, so it is nothing but equals to cot of phi. AO divided by OC is nothing but equals to cot of phi. Then what is OB divided by OC? So what is OB? This one is the distance OB. This one is nothing but the distance OB. Then what is OC? So this is the distance OC. This one is nothing but the distance OC. So this one is nothing but we can say it is the opposite side, and this one is nothing but we can say it is the adjacent side. So that is nothing but equals to what is OB divided by OC. So this OB divided by OC will be nothing but equals to tan of phi minus alpha. OB divided by OC is nothing but equals to tan of phi minus alpha. So what is shear strain? Shear strain, so we can get the formula. So shear strain, it is nothing but we can say it is nothing but equals to, that is the cot of phi. It is nothing but equals to cot of phi plus tan of phi minus alpha. Cot of phi plus tan of phi minus alpha. So if you know the angle phi, and the angle alpha, that is the rake angle, shear angle and the rake angle, if you know, so accordingly we can calculate that is the shear strain. So we can calculate that is nothing but the shear strain. So that can be calculated there. So I think you understood this, that how to calculate the shear strain So next thing that if you know Vs, the Vs, that is Vs is nothing but the shear velocity, if you know, and if you know the thickness of the shear zone, that is Ts, and if you know the shear velocity, that is Vs, and if you know the thickness of shear zone, that is Ts, then shear strain rate can be calculated or the shear strain rate can be determined there. And a shear strain rate that can be determined there. And that can be determined there. So what is shear strain rate? So it is nothing but we can say Vs, that is the shear velocity divided by thickness of shear zone. And thickness of shear zone. And what is the thickness of shear zone? So this thickness of shear zone is nothing but we can say it is Ts, and shear velocity, that is nothing but Vs. So accordingly, if you know the shear strain, if you want to calculate, that is the shear strain rate, and if you know the shear velocity and the thickness of the shear zone, so we can calculate. So that is nothing but called as a shear strain rate. And so there we can calculate the shear strain rate. So here we can say shear strain rate is nothing but equals to this Vs divided by Ts. So accordingly, if you know the Vs, if you know the Ts, the shear strain rate that can be calculated there. So in the numerical again, if it is asked to calculate the shear strain rate, and if the Vs and the Ts if it is known, so accordingly we can say the shear strain rate, so that can be calculated there. And that can be calculated there. So this is what is the shear strain that can be calculated there in the actual practices. So basically we know that how the material is going to be cut there in the actual practices. From the mechanics of metal cutting. So same here I have drawn, and same sketch here I have drawn there. And we can say this one is the workpiece like this, and this one is the workpiece like this. And I will try to draw the workpiece. Okay. And this one is the workpiece like this, and I can say this one is nothing but the cutting tool. And so this one is nothing but the cutting tool. So this cutting tool is moving like this in this direction, and because of that material is going to be cut there. So same sketch I have drawn, whatever this sketch I have just now I have drawn there by using the pen. So same I have plotted. Same I have shown there schematically, and same I have shown there schematically there. And I have shown there schematically. So here we can say from this particular point, the tool has started moving from this particular point to this particular point, and it has started moving from this point, and it has reached to this particular point. So here this one is nothing but the workpiece as usual, and this one is nothing but we can say it is the cutting tool, or this one is nothing but we can say it is the tool which is moving with a certain velocity, and because of that material is going to be cut there. So if you consider the angle, there, so we can say in the actual practice there is angle, this angle here you can observe that this angle here. So this angle is nothing but we can say it is the angle, that angle is nothing but we can say it is called as approach angle. And this angle is nothing but called as the approach angle. That is lambda. And this angle is nothing but called as approach angle lambda. So if you consider this angle, and if you consider this angle, so we can say this angle is nothing but the side cutting edge angle. And this angle is nothing but we can say it is the side cutting. This angle is nothing but we can say it is the side cutting edge angle. And this angle is nothing but we can say it is the side cutting edge angle. So here we can say this is nothing but the side cutting edge, and here you can observe, I can take the another color. Okay, so here you can observe this one is nothing but the side cutting edge, and here we can say this cutting edge is nothing but we can say it is the end cutting edge. And so this one is nothing but the side cutting edge, and this one is nothing but we can say it is the end cutting edge. So whatever this angle which is made, so it is nothing but the side cutting edge angle, and just listen. So this is nothing but the that is the end cutting edge. So whatever this angle which is made by this end cutting edge, so this angle is nothing but we can say it is the end cutting edge angle, that is CE. This angle is nothing but we can say it is the CE, that is the end cutting edge angle. So here we can say whatever this particular angle is there, and whatever this particular angle is there, this one. So this one is nothing but we can say this one is the end cutting edge. So because of that, this angle made by this shank, so that angle is nothing but we can say it is the this one is the side cutting edge. So accordingly, this angle is made by the shank by the side cutting edge. So this angle is nothing but we can say it is the side cutting edge angle CS, and a side cutting edge angle CS. So here we can say this one is the side cutting edge angle, and this one is nothing but the end cutting edge angle. So in the same way, here also this one is nothing but we can say this one is nothing but the side cutting edge angle, that is nothing but the CS, this one side cutting edge angle, and here we can say this one is the end cutting edge angle. So just remember here that angle made by the side cutting edge with a shank is nothing but we can say it is the side cutting edge angle. So accordingly, here we can find this one is the side cutting edge angle, and whatever this angle which is made by the side cutting edge angle with the workpiece, so that is nothing but called as approach angle, that is nothing but the lambda. That is nothing but the approach angle, and that is nothing but we can say it is the lambda. So cutting tool has started moving from this point to this point. So what is this distance? So basically we can say cutting tool has started moving from this point to this point. So that is nothing but the feed which is given to the cutting tool. So here I can say what is this one, this distance. So this distance is nothing but I can say it is feed, that is the F. And this distance is nothing but we can say it is the feed, and that is nothing but we can say it is F. That distance is nothing but we can say F. Then this point, and from this point, this distance. So from the geometry, what is this distance basically? So this one is nothing but this is the distance, and this is the distance there. So what is this distance? So this is nothing but the width of the chip which is going to be cut there. And so this distance is nothing but we can say it is B, that is the width of the chip which is going to be cut there, So what is this distance? This one. What is this distance here? This one. And what is this distance here? This one. And so basically this is the distance, and here also you can observe that here this one is the distance there, and this one is the distance there. So what is this distance? This distance is nothing but we can say it is the depth of cut. It is nothing but we can say the it is nothing but what is it? It is nothing but we can say the depth at which the material which is going to be cut there, and a depth at which the material which is going to be cut there. So that is nothing but we can say this distance. So that is nothing but we can say it is the this distance is nothing but we can say it is the depth of cut, and this distance is nothing but we can say it is the depth of cut. So here I can say this one, this distance is nothing but we can say it is D, and this distance is nothing but we can say D. So here again we can measure another distance. So if you draw the vertical line like this, and if I extend this one, and if I draw a vertical line like this one, and if I draw a vertical line this one, this distance, and if I draw this distance, so this distance, so it is nothing but we can say it is T, and this distance is nothing but we can say it is the thickness, that is T, and this distance is nothing but we can say it is thickness, that is nothing but we can say it is the T, and it is nothing but the T. So again, see once again, listen here, as usual. Just now I have told that this one is nothing but the workpiece like this, this one is nothing but the workpiece like this, this one is the workpiece, then this one is nothing but we can say here this one is the cutting tool like this, this one is the cutting tool like this. So this one is nothing but the end cutting edge, angle made by the end cutting edge, that is the end cutting edge angle. Then we can say this one is the side cutting edge, So whatever the angle which is made by the side cutting edge, so that angle is nothing but the side cutting edge angle here. And here I can say this angle is nothing but, we can say this angle is nothing but the approach angle, that is nothing but the lambda. That is nothing but the lambda. So same thing I have represented over here. So here we can say from this particular point, the cutting tool has started moving from this particular point, and it has reached to this point, and it has reached to this one. So what is this distance? So this distance is nothing but, we can say it is the field which is given to the cutting tool. And so from the definition of the field, that is the distance travelled by the cutting tool in one revolution of the workpiece. And so here also you can observe, from this particular point the tool has reached to this particular point, so that is nothing but the field which is given there to the cutting tool, and a feed which is given there to the cutting tool. So what is this one? This one is the width of the chip, which is going to be cut there. So here I have shown over here the same, that is nothing but the width of the chip. Then we can say what is this distance? This perpendicular distance. So here also I can draw the same thing, and in this diagram. So what is this distance? This distance is nothing but, we can say it is the uncut chip thickness, that is nothing but, we can say this is the depth at which that is nothing but the d, that is the depth at which the material which is going to be cut there, and the material which is going to be cut there, so that is nothing but, we can say it is the d, and that distance is nothing but, we can say it is the d. So here also you can observe this distance, that is this distance is nothing but, we can say it is d, and this distance is nothing but, we can say it is d. So if I draw a line, if you try to measure this distance, and this distance I am talking, that is from this one to this one, and this distance, and whatever this distance is there. So this distance is nothing but, we can say it is the thickness of the chip, that is nothing but the t, and it is nothing but the t, that is the thickness of the chip. So that is nothing but, we can say it is t, and that is nothing but t. So same I can draw, and same thing I can represent there here in this diagram, and same thing I can represent here in this diagram. So here this one is the tool, this one is nothing but, we can say it is the cutting tool, this one is the cutting tool, and on the cutting tool, so this one is the chip which is formed there, and this is nothing but the chip. So what is this distance? And so what is this distance? If I measure this distance, that is from this point to this point, and from this point to this point, so this is the distance, and this one is nothing but the distance. So from this point to this point the cutting tool has started moving, so this distance is nothing but, we can say it is the distance travelled by the cutting tool, so that is nothing but the feed, and that is nothing but the feed, and so this distance is nothing but, we can say it is feed. Then what is this distance? This distance is nothing but, we can say that is the width of the chip, and this distance is nothing but, we can say, and so same thing whatever I have shown over here, so same thing I am drawing over here, and so this distance is nothing but, I can say it is the width, that is b. Then what is this distance? So this distance is nothing but, I can say this is nothing but the depth at which material is going to be cut there. So this is the distance d, and this one is nothing but the distance d. This one is nothing but, we can say it is the distance d. And if I draw a line here over here, and if you measure this distance, and if I measure this distance, so this distance is nothing but, we can say it is, this distance is nothing but, we can say it is the thickness, that is the t, and this distance is nothing but, we can say the thickness, that is nothing but, we can say it is the t, and that distance is nothing but, we can say it is the t. And if I draw angle, if I measure this angle, so this angle, and this angle, so what is this angle? So here also we have set this angle, this one. So this angle, it is nothing but, we can say it is lambda, that is the approach angle, and this angle is nothing but, we can say it is the lambda. So that angle is nothing but, we can say it is the approach angle, that is the lambda. Approach angle, that is nothing but, we can say it is lambda. So accordingly accordingly what will be this angle? So this angle will be nothing but equals to lambda, and this angle is nothing but equals to lambda. So here you can find that if the value of the lambda is this much, and whatever the value of the lambda it may be, so if the value of the lambda, that is the angle, approach angle, if this much, in that case these are the values of this thickness, then we can say feed, then we can say width of the chip, as well as the depth of cut we can get there, and we can get there. So according to the angles which are there, whatever the value of the approach angle is there, so according to that we are going to get whatever the values of the approach angle is there, that is lambda. So we can get the values of this t, then we can say this is the value of f, then we can say this is nothing but the width, and this is nothing but the depth which is going to be there, if you going to be there. So accordingly what we can do, whatever this lambda is there, that is the approach angle, so this lambda can be increased or lambda can be decreased there. And when this lambda is increased or decreased, what is happening as far as this all parameters are going to be concerned there in the machining, so that we will see there in the next lecture. So only 3 minutes are remaining, so we will see this in the next lecture, that what will happen if these values of the lambda, if it is increase or decrease there.